What if you needed to secure AWS services supporting 4 billion users? I'm Robin Rodriguez, a solutions architect at AWS, and I'm super excited to be here with Akansh Grover, a production engineer at Meta, talking about how Meta secures AWS services at hyperscale. So, Meta is on a mission to connect the world. And to help accomplish that, they've built tooling to enable their developers to deliver secure and private services globally. We're going to talk about Meta's AWS organization setup and how dynamic service control policies allow them to approve AWS services for use, improve their incident response, and increase developer efficiency. And I'm going to pass it over to Akansh and take us away.
Thank you, Robin. This is the high-level organization tree view in Meta for AWS accounts. Account lifecycle starts before even creation of an account in Meta. We have built a portal to collect all the information about account usage, why it's being created, what type of data is going to be stored in that account, what type of network architecture is going to be deployed in that account. Based on all that information, we can place the account in its correct OU. OUs are just organization units, which allow us to logically deploy SCP controls on a collection of accounts. It helps scale our policies. It helps us be compliant at scale. It helps us make sure our accounts are secure by default. Top-level OUs, as you can see in this tree, are staging. Staging is where an account will go before we give it to a user. It's where the account will stay as we are setting it up, as we are deploying our policies, as we are deploying our canned rules, our visibility pipelines, our monitoring pipelines in it. Once the account is ready, it goes to main. Under main, we have multiple OUs. Where your account goes under main is determined by the use case for your account. DMZ is special. DMZ is free of every policy we put in this organization. DMZ is for use cases like where you need to use root. We block root everywhere in AWS. So if you ever have to use root, your account goes to DMZ. We log into the account as root. We do our thing. We move it back to main. Suspended, we've created a special OU for compliance reasons. If an account has been abandoned, if we detect nobody's using the account, resources are at risk, it goes to suspended state. We cut off all the API access to AWS backend. It remains there. Nobody can exfiltrate data. We can all have a nice sleep. Lockdown is for incident response. If we detect something malicious going in an account, someone mining Bitcoin, a malicious actor from outside accessing an account, it goes to lockdown. We have other things apart from blocking access to AWS backend. We block NACLs. We block all the network connections. Lockdown is where our incident responses can go in, investigate, figure out what's happening, and stop the bleeding. Prod and dev are two main branches under our usable organization. Everything green is where we enforce infrastructure as code. We do that via Terraform. We built a tool called Cloud CLI, which is a wrapper around Terraform. We force the usage of Cloud CLI in every account in the green node. It helps us make sure accounts and resources are secure by default. People are using the modules you have created in Terraform. You have to go through code reviews to deploy any kind of resource in this part of our organization. Dev and Sandbox are for experimentation. Sandbox is where we send users while they are iterating over their architecture. If we want a user to play in console, Sandbox is where we send them. Sandbox accounts are temporary. We allow usage for 2 weeks and then they're gone. This helps us mitigate. This helps our users move faster, experiment faster, but also at the same time we don't want to push that code in production. So it helps us keep the separation. So at every OU level, we have multiple static policies. These are some of the examples of our static policies. Under production, like I said before, we only allow resources to be created via Terraform. This helps us be secure by default because we have a lot of Terraform recipes. If a user wants to deploy S3 bucket, they have to use our S3 module. That's how they deploy their S3 bucket, and we can be confident that they'll always be secure by default. Sandbox and dev account is where we want experimentation to happen. We allow users to use console there. We do still have some controls on Sandbox. For example, we don't allow them to deploy expensive GPU resources in Sandbox accounts. Helps us keep down the cost. DMZ is special. Like I said earlier, root is blocked everywhere in our organization except for DMZ org. But there are some actions in AWS which can only be done as root. So from time to time, we'll have to move an account into DMZ, do our thing as root, bring the account back. In case we forget an account in DMZ, we get an alert. We have to mitigate it immediately. It's very risky to leave an account in DMZ for too long. It's suspended state. We cut off access to all the AWS backend APIs. It helps us get attention from a user who are violating a policy, who have abandoned their account, whose resources are unmanaged. We want to get their attention, bring them back into compliance. If they don't respond to us in timely manner, their account is gone. Lockdown, like I said earlier, incident response. If we detect, and we can confidently say there's some malicious activity going in your account, it immediately goes to lockdown for you. There you can't. Apart from cutting off access to AWS backend APIs, we also cut off network in lockdown, which helps us keep secure, stop the bleeding, no exfiltration of data. So apart from statically configured SCPs, we also have written a lot of code to dynamically generate SCPs. Facebook has to deal with a lot of privacy compliance all around the world. Meta is active across the world, different standards across every country. One of the craziest standards we have to deal with, every service which can store or process data has to go through explicit approval from privacy. So for example, if you in AWS want to use S3, you have to explicitly ask for it. You have to get an approval from privacy, and only then you can use S3. So we achieve this using SCPs. So when a user shows up and they want to use AWS, they have to explicitly tell us which data or compute services they're going to use in their account. Based on that, we generate an SCP, custom to their account, custom to their use case, attach it to their account. Once they have the approval, the account is usable. They can use S3, they can use EC2. This requires explicit approval of services. This also makes sure the blast radius is not too much. In case something bad happens, account gets taken over. A malicious actor cannot just launch an EC2 machine in an account which is not approved for EC2 machine. Enrolling an existing account, Meta has to sometimes acquire small companies and bringing them back. A lot of these companies are using AWS, and bringing them in our organization, bringing them in our control is a complicated process when you have so many privacy controls, when you have so many dynamically generated SCPs. So build tooling using CloudTrail to analyze historical events, to analyze which type of services you're using, and then generate a dynamically created SCP for your account. This process takes a lot of time, but it's automated. We don't have to manually do this. It helps us be compliant, helps us be secure. How do we use SCPs for incident response? For incident response, we have built a lot of tooling using managed AWS services like GuardDuty, config, custom detections in CloudTrail, health events, third-party integrations using third-party tools. So combination of these tools can tell us if a malicious activity is going on in your account. GuardDuty can tell you about Bitcoin mining. Health events can tell you if an AKSK has been leaked. Things like that. Once we have a confirmed malicious activity actor in an account, in a resource in AWS, we take action. We have automated this part too using SCPs. For example, if we know someone is mining Bitcoin in our account, we immediately move their account to lockdown OU. We immediately cut off NACL. We immediately cut off network using NACLs on that account. Every VPC is cut off. Nothing can go out. Nothing can come in. Only our incident responses can access the account. It gives them bandwidth to go in an account, take their time, do the analysis, figure out what's compromised, and from there we can iterate over the future and how to improve our security posture. This part is critical for us. Even if we have a lot of these SCPs, this complicates development lifecycle for users. The more policies you have, the more controls you build, it can slow down innovation within the company, which we don't want to happen in Meta. Speed is very important to us. Moving fast is very important to us. But we still want to comply to privacy and compliance standards. So build our custom tooling using CloudTrail. For example, if a user goes to console, they try to create an S3 bucket. If it's blocked on their account because they're not using our tooling, they're not using infrastructure as code, we can detect that immediately in real time and send them a message to nudge them towards our paved path. What does it mean? You go to console, you get access denied on S3 create. We can tell you why that was denied, how we want you to create an S3 bucket using CloudTrail and just our processing event. This helps us nudge people on the paved path, guide people for secure cloud usage. Also, it helps us in cost optimization. If they're doing something expensive, which we don't want them to do, we can also push them to do the right thing. And with that, I'm going to hand it over to Robin.
Thank you, Akansh.